Empirical formula. Now that we're able to calculate the percent of a compound by the mass of each element, we can begin to identify unknown substances. First, we need the ratio of the number of moles, and that's why we spent so much time on the number of moles, of each element in the substance. This formula, which is based on a whole number ratio, is called an empirical formula. The empirical formula indicates the molar ratio of elements present in a molecular compound reduced to the least common denominator. Least common denominator. Not sure if that's algebra or what, but we'll be using it here. So for example, if we have benzene, which is C6H6, we divide both 6's by 6 to find the least common denominator here. So we just put CH. We have a flow chart. We start with the mass percentage of elements. We assume a 100 gram sample. We find out how many grams of each element we have. Then we use the molar mass, which we just worked on. That tells us the moles of each element. We calculate the mole ratio, and then we have the empirical formula. There is only one empirical formula for a substance, but two different substances can have the same empirical formula. Mathematically, A implies B, but B does not have to imply A. It could also imply somebody else. Okay? And that's because of this lowest common denominator business. So here's an example. You don't have to worry so much about this. Hydrogen peroxide is H2O2. We divide both of those subscripts by 2, and we come up with an empirical formula of OH. However, hydroxide already is in a lowest common denominator, which is also OH. So that implies that, and this implies this, and there we go.